Welcome to part 8 of our journey. It's the wrong screen. We're not there yet. Yeah, welcome. Let me quickly make sure everything's up here. Yeah, that looks good. So, last time we did the wiring, and I was like very optimistic and hoped that we can already print, but yeah, took a bit longer than expected. But today, for sure, we will print. I actually forgot to post the link to the stream in the Discord, but I guess people will find it anyways. Um, yeah, there's not much to say before we start, to be honest. I was looking for configuration from Formbot directly. Like usually, like when you build a kit, I would expect like a standard configuration to be provided. But there's none as far as I can see. So we will start with just a bare basic Voron 2.4 configuration. Let me see. So luckily, in the V0, in the Voron 2 GitHub, there's already configuration for the M8P. I actually have like different configurations for all the different versions, which is great because they're quite different as far as I can see. So we obviously have in my kit the 2.0, so we will go with this configuration. That should work out of the box more or less. Let me actually see if everything is up with YouTube because it looks a bit odd. Yes. And it's public. Let me see, let me quickly post it here as well. So, well, yeah, so we'll basically start with this configuration. There are a couple of things you obviously have to change. Firstly, we use CAN bus. This assumes we use USB, so that is a bit different. And then we kind of more or less randomly plugged the motors in. I actually took a picture of the software setup. I, as smart as I am, have it on my phone, and the phone is there recording me. So I'm not sure if I can access that, but if not, it's also no biggie. Oh, I can access it. Let me push this here. And then we should have everything we need. If I can get this image out of here. Oh, Chrome can't open that. 1 second. Quick actions. Convert image. JPEG. Here we go. So yeah, this is basically the hardware setup we have. So the steppers on the bottom are pretty much random. We did mark them though with Sharpie. So the first 4 are the Z steppers. You see this one has no Sharpie on it. That's the stepper 0. This should be this one. In the front here, then we have 1, the next has 2, and this one has 3. Hi there, Steve. Hi there, William. Welcome. So these are the Z, which corresponds to some stepper drivers on the board. We need to quickly figure it out. And then these are A and B. Also, there it's a bit random which one is which. So we kind of have to sort that out. Besides that, it should be quite straightforward because on the main board, we don't actually have a lot of stuff plugged in. The only things we have here are the Nevermore here. I think this is Nevermore, the bad thermistor. This is the canvas connection, so that it's not really like something we need to configure. This is a fan, but don't ask me what fan we plugged in there. We will find it out. And then kind of hidden behind here, you see the 2 connectors for the solid state relay, which control the heat bed. As I said, there's not much to configure, but we have a second board, of course. We have the EBB SB2209 in the Raspberry Pi 2040 edition, which is the newer model of that. Also here we have a configuration, which we can just use to start, basically. And this should be pretty much good to go. What we do need to configure is we use tap, obviously, so we need to configure that. But besides that, not much to change here, I think. Um, my idea is basically to have one configuration file for the main board and one configuration file for the toolhead board that's like a bit separate, and we don't have everything in one big ass file. Isn't it why it's not a fan? Could also be. We will figure it out. Most likely it's a Y and stop, and you're right. Yeah, it must be the Y and stop. But this one is, oh, this one is the Y and stop, and this one is the Nevermore. I was just thrown off by the black and red cable because usually I always use same color for for end stops because I really like power. But yeah, nevertheless. Let's also we also still have to open here. We do have the documentation here for the M8P. And there should be like a board overview, if I recall correctly. Yeah, here. Exactly. So this is also like very helpful for us in a second. Yeah, let's start. I don't think there's much to do. I'm gonna work in Visual Studio Code. So this is the same configuration, obviously, as we have in that does work. It's great. That's the same configuration as we have here in Mainsail. There is nothing I really did between the last stream and now, except for one thing, which is I updated all the OS packages, just to make sure everything's up to date. Clipper we kind of updated, but not properly. So maybe also let's actually start with that. Just to make sure that we have everything up to date. So what we did last time is I did a git pull in the Clipper repository, like on the command line. So the latest Clipper should be there already, just not properly installed. But for flashing, I hope it didn't really matter. We will find out in a second how the boards self-identify. But generally, I think it's always a good idea to first update all the things and then start working on the machine. So we should have done that before flashing the boards technically, but it should be fine. It says update finished. That was quick. We don't need crow's nest. We don't need. That's also, yeah. For the rest, let's just leave that for now. Like these are like super minor updates. The only thing that was Clipper is what was important. Yeah. Then let's just get going. So I'll just copy the configuration of the M8P from the Voron Discord, from the Voron GitHub. And then let's just create a new file called M8P CFG. And then I'll just paste. So this is the whole M8P configuration from Voron. And then we can just here say M8P CFG. So this is a printer config. We can just include that. So the CB1 is like the Linux controller we are running on at the moment. And this one has this Clipper host MCU installed. So you can also interact with the host. Not so important for now, but it is there. So let's start here with the configuration. So firstly, we need this one here. And this is for us not the serial, we have CAN bus. And now one should remember how this is called then. Clipper CAN bus config. I think it's called CAN bus underscore UUID. Let's quickly check that. That's not what I want. Yeah. CAN bus UUID. Yeah, exactly. CAN bus UUID. And somebody last time suggested, it was very helpful, to take a screenshot after we flashed the first MCU. Hi there, Pats. I have no clue how to pronounce here your nickname, but I just call you Pats. Welcome to the stream. So I'm very glad that I took the screenshot. Let me quickly pop that also in Chrome. So this is what we were looking at last time. It's just a screenshot from my terminal. So you can see the first board we flashed was M8P, and this one in this screenshot here was already running Clipper. And then the second one, catapult, is the toolhead board. So the ID with F8 is the M8P. When you are in the mainsail UI, you can always click on devices here. And then you get the CAN IDs also from here. You just have to know which one is which. So this one is the M8P we know with F8. And we can pop this in here. Well, I did that scroll all the way down. Here we go. Then, just for me to sort, so I want to have all the M8P configuration in this file and all the generic Clipper stuff in the printer config file. So I'll just quickly copy the printer out, and then we can paste that here in the printer config. So I'm not going to touch that for now. Let's just leave that as is. The important part is that we have Quark's Y motion system. Then temperature sensor is fine. Let's just keep them here. And then we are already on the steppers. So technically, what we could do is I'm almost certain that this would boot up. Like if we now save the config and just restart Clipper, I'm pretty sure it will just work. Like not work in terms of we can print work, but like work in terms of we can try stuff out. If you create a new config file for the mainboard, Clipper then will not be able to save config automatically, like pit, tuning, probe set, and shaper config. I'm fully aware of that because I have it with the other machines as well. But I still prefer to have like different files for the stuff, because otherwise like you have this like, massive config file. I really don't like that. But yeah, like it's a bit annoying because then you have to manually copy these values over. Yeah, so it's the stepper X. The main thing we need to figure out is like which stepper goes where, because I plugged them in anywhere randomly. But let's figure out steppers in a second. So we have a 300 built. So let's just take the 300 values. Then we have 2209s, which I guess is fine here. So we can also remove this comment. The Y stepper. Again, we need to check the pins in a second because I'm not sure in which one I plugged it in. We don't have 0.9 degree steppers, so we can also remove this one. Then we have 300 built in my case, so we remove these. Then also here, this is fine, 2209s. Then Z. Helpfully it tells us here also again like which one is which. So front left is this one, which is here model 3. I'm not sure if we got lucky randomly. So this is 0, 1, 2, 3. Which is completely wrong. So we definitely have to sort these. We have to sort these in a second. But yeah, that's not too bad. Then Z position of nozzle millimeter to Z end stop trigger point relative to print surface. Where does this what does this relate to? Position end stop. Position end stop for us will just be 0 because we have tap. So basically like the end stop position is exactly on the bed. But it's also something you can really easy later adjust. So it's not super important for us. And then again, we have the 300 built. I always thought the 350 has the same Z as the 300. What's the difference between the Pro Kit and the regular? I actually do not know, to be honest. I'm not quite sure if you refer to the Formbot kit, I mean, I think. I'm not quite sure if there's a regular at all. I think they're just all Pro. Hi there, Alex, welcome. So then, this one again, like we have 2209s, that's fine. We have more steppers here. we can just remove that. It's all fine. The thing with, if you have more than one Z stepper in Clipper, the stepper Z has all the configuration basically. And then you have steppers at 1, 2, 3, and so on. And these are only like configuring basically the stepper itself, but not like the end sub positions and stuff like that. That's all copied over from the first. Then we are done with all these Zs. Again, we have to shuffle the pins in a second. Extruder. And this is now basically where this configuration completely goes wrong for us, because the extruder is not configured here. So I would just remove that now. Like all the stuff we don't need. So extruder we don't need. The heater we actually need. This should be correct. Let's just check all the pins in a second. Sensor type. And this is not something we need to look up because I am not sure. Adjust power so it doesn't exceed SR rating. The Omron G3NAA is rated for 4 amps without a heatsink. The formula is if max power is greater than 1, we'll use 1. Okay, so two things we need to figure out. First, we need to figure out what kind of thermistor we have for the bed, and then what kind of SSR we have. So let's quickly check. Check the, I guess, where can we check? Let's quickly check in the Formbot in this introduction GitHub. Thermistor. The heated bed has an NTC 100KB 39050. So I assume this is the same. Like, this is the older version of the kit. I have the newer R2 version, but I assume it's the same one. So let's just roll with that. If the thermistor is wrong, like, the temperature reading will be completely off. So that will be quite obvious to spot. Then, oh, Chrome is gone on the side. That's sad. Interesting, pretty sure I've seen Voron 2.4 R2, and it's the first time I've seen the Pro Plus kit. Are you sure? I mean, like, I'm not like an expert for Formbot stuff, to be honest. I have no clue. I actually don't have the webpage open. Formbot 2.4. And I think if you go there, and you go to 3 printers, there is, this is the 2.4 R2 Pro Plus. And this is the only 2.4 I can see here. So I'm pretty sure there's only the Pro Plus kit. Like, maybe in the past there have been other ones. I mean, there have been different iterations of this kit for sure, because here we have completely different specs. Like, this is what they link from their page here. Like, this is linked here, guide. But this has a completely different thing. And this one is the technically also Voron 2.4 R2 Pro Plus, but it's definitely different. Different than what I have. Oh, this is the R2. R2 is what I have, and then maybe this is not the R2. I have no clue. But also here they don't have config, so not really helpful for us right now. Yeah, it's a Formbot thing, most likely. Bed and extruder, you don't calibrate very often. No, that's true. Like, I mean, typically bed you would do once, right? Like, I wouldn't know I would do that again. Extruder, or like the hot end 2. So that shouldn't really matter. So here we said it's a generic 3950. I need to uncomment that. Then we can also remove this one. Then the SSR. The question was what kind of SSR we have. That's the only mention of SSR here. Let's quickly check if... Oops. Let's quickly check if they specify this here. Otherwise, we have to quickly flip over. Now, they also don't say anything SSR. Then let's quickly do like... inspection of what we have here. Okay, so it's exactly, no, it's not. So I'm gonna just type that here. I'm not gonna adjust the camera now for a second. That's G3 NV. Does it actually say? Oh yeah, it's actually rated for 10 amps. It's rated for 10 amps. It just says on the front. So the one I have is rated for 10 amps. Then let's quickly use this fancy pants formula here. Well, most likely it will end up being exactly 1. So it is 4 divided by wattage of the heater bed. Well, I think let's just go with 750 divided by 240. And that's 1. So the result is 1.28. So we can set the max power to 1. I think the big difference here is the mains voltage, because like I'm in the EU, so my mains voltage is 240. So that makes a huge difference. If you're in the US and the mains voltage is 110, the amperage of the bed will be much, much higher. And I think then this becomes a problem. But for 240, it's most likely not really a big deal. So we can kill this. Then inductive probe. We don't have a probe that's inductive, and we don't have a probe on that main board, so we can also completely remove that. Fan control, let's leave that in. But we don't have fans yet installed, so I would just leave that for now as is. Let's not touch anything in fans. LED control, same thing. We actually have this weird light bar here. I'm not a huge fan, to be honest. Like, we will install it, but most likely will be replaced quite quickly. But this will be controlled here, so we can leave that in as well. Idle timeout is something printer generic. So I would move these over. Like, these are just a quad gantry stuff. Let's just move these over to the printer. And here we are not on a 350, we are on a 300. So let's just uncount these. Let's just clean it up. So that's a quad gantry level. Then 170, 170 should be fine. So it's basically like the position where it tries to home that. 170, 170 is kind of like, I mean, you can just do 150, 150 to have a dead spot center. So for us, it doesn't really matter because we don't have this end stop switch. So if you have this end stop switch on the side of the bed, this is important, right? Like, because you need to home on the switch, but we don't have that at all. So potentially we have to change it completely. Let's just leave it out for now. Then we have these board pins, which we also don't really use because we don't use the expansion header. So let's just remove that. Display, we don't have a display, and the display we are going to have is the clipper screen, so that's completely separate. We also don't have NeoPixel. We also don't have NeoPixel that we can set with delayed G-code. Okay, check. Then we have macros. It's G32. Print start, print end. Let's just take them and throw them in a new file called macros. This is something we will work on a lot. So doesn't really matter, but let's just throw it in there. Then we also include the macros file. Check. And that should be it. Let's just do the second board as well. So I just make a new file called EBB CFG. And we include this here right away. Sorry, Valzo, I totally missed your comments. I'll be getting more Trident at some point. I was planning on 2.4, but I was convinced to get the Trident. Why did you get convinced to get the Trident? I mean, it's both cool printers. I don't think there's really like a strong case for one over the other, to be honest. Trident is a bit simpler because I have one less motor. Besides that, I think they're quite similar. Definitely solid choice either way. So EBB, I'll just copy the whole shebang and just paste that here. Lot shorter. Then I will do one thing. I rename this. Let's just search and replace EBB can. I will just rename to EBB. Check. Then we connect via Canvas. And the Canvas ID we also have here. So we know the F8 was the main board, so we use the EF. Hi there, Prototype 15, welcome. Just popping by real quick. What you're doing seems like a resource for learning. Yeah, that's kind of the idea. You know, I'm doing it wrong, and then you can do it right. It's usually how it goes. I do like to find Gantry, but Trident is probably easier for the first time builder. Yeah, I think that's one of the main arguments to get a Trident. It's just like it's a bit simpler to put together. I mean, for me, we will find out if I did it right in a second. So, I think we have actually PT1000. But I am not 100% sure on that. Let's quickly pop by at the Formbot again. Yeah, they don't describe anything like this. There's not really like a, usually if there would be like a nice bomb. Oh, there is. It's an image. Perfect. Let's quickly check. Electronics. We have Omron. Oh yeah, so here would have been the Omron SSR. That's good. It's the same I have, so that's at least correct. Then so there's a PT1000 temperature sensor here. And I think this is what we are running on the hot end. I would assume. Let's configure it as PT1000. And then again, like if it's not the PT1000, we will find out very, very quickly that it's not. But the things like just this hot end kit. So the chances are that this one is for the bad and not for the hot end. It's PT1000. Okay, let's roll with PT1000. Just programming a printer. Basically, just programming a printer. Well, although the most of the programming is already done, we just configure everything. Yep. Something is not going right today with my switching of applications because now Chrome is gone again. You can't have it all. Then I think this is just a PT1000. Let's take a quick peek in the EBB documentation. Build guide. Let's not go for the Chinese one. Let me quickly download that. And then this should most likely tell us which pins that is, because for the PT1000 it's most likely a different pin. Or is oh, it's the okay. I think we need to quickly check because I do not remember if we have 4 or 2 wires. I think most likely, if I recall correctly, we have 2 wires. Yeah, I'm pretty sure we have 2 wires. I remember 2 wires. Um, it does not specify then here the pin, but I think that for 2 wires it's just the same. So let's just roll with PT1000 and GPIO 28. Should be fine. Then ADXL, let's not touch that. Resonance tester, no reason to change that. Extruder, we don't have to change that. Wait, I made a mistake. This one is the temperature of the like the chamber temperature, and this one here we have the PT1000. Then so quickly, I'm pretty sure it's just PT1000. But let's quickly check the clipper configuration. It's the max chip in the config 2 wires. Yeah. And I think this one we just need to change to PT1000. Sensor type. But I don't see a PT1000 here. Yeah, it's just PT1000 most likely. Clipper will complain if it's not. Oh, sorry. Like something is wrong when I switch the applications. Like sometimes it just craps out Chrome. Sorry for that. Sorry for the black screen. Sensor type PT1000 and sensor pin. Let's not change that. The PID tuning values is something we need to update in a second, like when everything is up and running. We need to do a quick PID tune. I am not quite sure what this refers to. Let's just leave that here for a second. Then this is the TMC extruder. Run current 0.6 is maybe on the high end for such a stepper, but let's leave it for now. Then we have fan, let's not touch that. Hot and fan, let's also not touch that. I think there are 2 options to plug in the fan. So potentially we need to see if it doesn't work, we need to quickly check the configuration. We don't use the 4-wire fan, so this one can definitely go. Then hot and RGB, very important. And BL touch is not something we do. But we have tap. So we need to quickly check how to configure tap. You change the jumpers on the board. Yeah, exactly. Like we just adjusted the jumpers, and I think the configuration will stay the same. Just after extruder and config. You mean I have to adjust something here? But let's quickly check. Now Chrome is back. That's nice. Oh, I think I have an idea what's causing the black screens. Let me turn off this. The tab. So Voron tab config. Let's see if they have a config here, but most likely it just acts as an end stop. It most likely just acts as a normal end stop. It's just 2 wires, so I don't think there's any special configuration we have to do for that. The only thing is what we need to figure out. I mean, you can also quickly check here. This is the X limit switch. I think this, I didn't see it. Voron tap. Exactly, this is what we have. We're using the SP22 with one tap. That's just a wire. Yeah, but it doesn't even tell you the configuration. So I think it's really just straightforward. Let's quickly check. Sensor pin. Sensor pin is then basically our end stop. So this is not correct. It's definitely not build touch. So I think we need to say probe. And then I assume GPIO 16 is the correct one already. We will test it in a second, so it's not a big deal if it's not correct. Then I think this is it. I did not see a X limit switch though. I did not see the X limit switch. And it does not. It doesn't tell us the pinout here. It's very sad. Let's see, is there any diagram here that tells us the pinout? EBB 2209. Pinout. Let me see. There's no pinout? Very sad. I'm looking for this. But then for the correct board, I think this one is the wrong. This is the wrong version of the board. Let's quickly go to image search. You need the macro for tap. That's a good one. I'll check that in a second. Yeah, I'm looking for this, but this is the old version of what I'm having. Which is really weird. I would expect like a million of these images here. Also weird that's not in the... This looks like what we need. Yeah, this is the old version here, and this is the new version that we are having with the RP2040. Very good. End stop. GPIO 24 is the end stop header here. I'm fairly certain that we used that end stop header. So it's GPIO 24. What is GPIO 6 is my question then. This is this header here, it's GPIO 6. Then the question is, which one did we use? Most likely use the answer one. Let me quickly pop it open and just let's take a look. Oh, I didn't even get out my tools. Let's quickly take a look. See, BT29 git, there is a pin out. GPIO 24. Yeah, it's also what I have here. I did see the I don't know, like every time I need to have documentation for the 2209, like the EBB, I always look for it and I never find stuff. And if I find it, I use the wrong board. I also have more than once. So we are on the pink one here, so it's GPO 24 for sure. Then Mr. the DSI mentioned in the Voron tab, we have, oh, there's a config folder. Yep. Let's take that. So we have the probe. Yeah, the save that we already did. We need to check the stepper Z configuration that it homes correctly. Okay, then probe is pin 24. I'm not quite sure if we need the pull-up thingy here. Let's just leave it for now. I'm never sure with these. Oh, I'm in the wrong one again. So I'm never sure if I need this little like pull-up resistor or not, but let's just leave it. Important is the activate G code here. So it's basically like what is run when the probe is activated. Then the XY offset should be 0. I'm not sure if we actually have to define those, but let's just go for it. Oops, that's 2 times X. Let's try maybe 1 Y. And then we need this probe set virtual end stop. So this is then in the MAP folder here for the stepper Z. And here we have end stop pin, which is not this one, but the end stop. Oh, no, we have end stop pin probe Z virtual end stop. Then update your Z homing position. This is what we already did, right? We did the safe home. Save. Oh, we put it in the printer. Safe home Z is 150, 150. So it's the center of the bed, so that's perfect. And I think that is then it. And all the activate G code does here actually is just like check the target temp. Because you touch the bed with the nozzle, you don't want the nozzle to be too hot. GPO 24 is for X. Oh yeah, you're right. My bad. We used the prop port. I mislooked. X end stop is EVB22. Let's move that over. End stop pin is EVB. Yeah, also with this. GPO 22 is then the correct one because we use this. And then I'm not configuring the runout sensor now, but this would be the GPO 21. Maybe let's quickly configure that while we're at it. 22. EBB 22. Then let's quickly check the configuration reference. Yes. So then we use filament switch sensor here. I'm just copy the whole block. And then we can quickly configure that. So pause and run out, sure. If it's reliable, I'm happy. Like on my V0, I also have a runout sensor, but it triggers sometimes randomly. It's like super annoying. That's why I disabled it. Run our G code, we don't need that. Insert G code, we don't need that. Event delay, events. Let's stick with the default 3 seconds. Pause delay, debounce delay, switch pin. And the switch pin is what we actually want. And this is 21. 21. Check. Hi, Neo. Welcome. I probably should get it quite soon if I don't figure out what is wrong with my current printer. I probably have some bad contact on the heater since it sometimes doesn't start heating. Oh, that's actually quite dangerous. You should check that out. If you have a multimeter, that's the first step I would do. Like you have the multimeter and then you have this continuity mode where like if you put the probes together, it beeps. And then you can just check where it's broken. Also visually inspect the cable. If the cable is along the entire run is damaged somewhere. If there's like bare metal showing, basically, that's not good. It might just be broken cable. On the film environment sensor doesn't work as the EBB GPO21 doesn't work. Oh, it doesn't work? Some of these like pins are sometimes like connected in a funky way. I also noticed that, and I am not sure if it actually was with the EBB 2209. I remember we need to check my switch wire. We bridged some pin there. We did something to the board, but I'm not sure if that was because of the probe. Let's kind of like put it to the back of our mind and see. I remember there was something here where we bridged. We soldered a small wire to something here in this area. I don't remember what exactly we did there, but something rings a bell. Oh, wait, I'm on the wrong one again. Sorry. Yeah, we soldered something here in this area. And I don't quite remember what we did. But yeah, we'll check and compare. Clipper says today, lol, it just shuts down everything. Yeah. Just remember the old Marlin printers, like from like, I don't know, like 10 years ago, and they were like all like badly configured Marlin printers. Like Marlin itself can handle that just as well as Clipper. But like they weren't properly configured. And then you had like, what was this? I want to say it was this Anycubic printer, like the super old ones. There was like this Ender 3 clone that burned down a couple of apartments because of like stuff like that. But yeah, it's not super dangerous anymore because like stuff is properly configured, but technically it can be dangerous. Okay, then. I mean, we can just give it a shot, to be honest, and see what it does. So let me just check. We saved everything. So technically, like it will have an error, but let's just see what happens. Yes, Z offset needs to be configured. We didn't do that. So let's just do it here. We configured X and Y offsets, but we didn't configure Z offset. That was very, very stupid of us. Then, position and stop is not valid in section stepper Z. Yes, let's check this one. So, the position end stop is most likely not valid here because we have the end stop pin probe. So most likely we have to remove that. Yeah, this is now for the next couple of minutes. We'll just trial and error. So now basically config is correct, but immediately went to shutdown. And yeah, this is what I mentioned before. Let's see, can I? So now basically it tells us that the sensor extruder temperature is not in range. And range is 0 to 250 degrees, and the temperature is surface of the sun. So also, this is exactly what will also happen for you, where for you it will be like most like heating not at an expected rate. But this is one of these like security features. So now the temperature sensor does not properly measure the temperature, and that trips immediately like some safety stuff. This means for us that the temperature sensor is not correctly configured. Most likely this means it's the wrong pin. Let's stick here. Like if I switch, like it blacks out, so let's just stick here. So the temperature sensor here is the sensor pin is GPIO 27. Let's just quickly check what that would be. 27 is correct here, so this is the correct pin for the temperature sensor. It is not. We have it plugged in here. So it's GPIO 9, most likely. I have two cables there in these two pins. So it's GPIO 9. Let me correct that. Let me actually also close a couple of tabs that we don't need anymore. Yes, we will need. GPIO 9. So let's just change that. I didn't configure the max chip in the EBB. I need to configure. I never use the max chip, so I am not sure if I have to configure that. Ah, yeah, I see. Okay, now I understand also what you said before. So this is what we need. Okay, I got you now. And then this needs to go, and this needs to go because we have it here. Okay, check. Sorry. I didn't understand before what you mentioned or what you said. So yeah, that was it. Easy. That looks good. So it is up and running. So no security stuff was triggered. Let's start. We already work kind of on temperatures. Let's just work on that. So what you want to do basically as a first step is always like, in my case, you see the temperatures. Oh, you don't see the temperature. Ugh. Let me just put it like this for now. You see the temperature is like 23 degrees. So let's just put it to 30. And now a couple of things should happen. Firstly, you see the temperature is rising. That is good. That means the heater is working and the temperature sensor is correct. The other thing that happens is, maybe let's actually get the camera down here. Maybe that's better. To that a bit closer. Now you just have to live with my face being half covered by that bar, but I guess you can survive that. You see now here the fan is also spinning, which is amazing. So the hot end fan is working, extruder is working, top, and the fan also stops again. That is great. Okay. Then let's quickly check the bed. I have a bit of like respect because it's a AC bed, but if I'm gone in a second, we have a short. Okay, no short, so check. Let's see if something happens. I don't think something happens. Like it's a slow-ish, but there's nothing happening so far at all. No, that's not working. Definitely not. Okay, let's quickly turn this off because we'll like go in a error state anyways in a second. Let's quickly double check what we did here. So we have heater bed. PA1 is the pin we have. And also recalling here the image we have is we use the second one. Steve, you say wrong enable pin. That is most likely what I think as well. We just need BTT M8P pinout. Do we have? A pinout, we do. So, and we are here at hot end 1, and this is PA1. That should be fine. PA1, that's fine. The sensor is also fine. We see the correct temperature, so that's all good. So I think from this perspective, everything's fine. Let's quickly flip it over and take a look. Let's take a look what we have here. So just looking at it, everything seems to be fine. So not sure if we have a software or a hardware issue. Should there be, the LED should be on if we power it, right? Yeah, that's what I thought. Like, I think that's a LED, right? Like if somebody with a bit of experience with these can tell me yes, then we can be certain. But I think this doesn't have or doesn't trigger. Way to make a feel about my chaos management. Yeah, I think it's actually turned out really well. I mean, there's not everything is in here yet, right? Like a couple of things are still missing. So we can still screw up the cable management. Yeah, LED will flash, exactly. So that most likely means something is off between the main board and the SSR. Let's see. So it's really simple. Like I don't know what could go wrong there. Is it polarity sensitive? I mean, we can try to swap it around. That's not a big deal. Well, I think I paid attention to polarity because the red wire here is on plus, negative is minus, and here I think we also paid attention, but we can check. Yes. Yep. I definitely need to get like a new clamp for here. Like this is like super annoying sometimes to like adjust the camera. And the cable is too short. We have to quickly unplug that here. And I did shut down the Pi already, so. No, it's incorrectly here. So the polarity here is incorrect. It's a bit confusing from the labeling, but it's incorrect. Let's just quickly flip them. Let's just keep it like that for now. PA1, yeah? I think I have PA1, Steve, right? Let me check. Stepper, stepper. Fan, heater bed. PA1, yeah? That should be correct, Steve, right? You should be in PA0, PF9 is the Nevermore. Yeah, PA1. I have PA1. I should be correct. Maybe you plugged in hot and 0. No, it's hot and 1. That's correct. Is it a better printer than a Bamloop H2D? It's a different printer, and it's a third of the price. Like the Bamboo Lab is something if you want to just print. If you want a hobby, then this is the machine for you. For me, it's more about the fun. I want to tinker with the machines. I want to tune it. I want to build more stuff onto it. The Bamboo Lab is just like it's like an Apple device, basically. You buy it, and as long as you don't do anything that they don't or they do not want you to not do, or they do not want you to do, that's the way, then you will be happy. But if you want to do anything else than what Bamboo Lab wants you to do, then this is the machine. um, let's see if this is back online already. It is. Let's try this again. Actually, I shouldn't have flipped it over because I kind of want to see the LD. Put it back on the side. Yeah, let's try again. Yeah, now we have a LD. That was it. I have the LD confirmation here. You also see the green LD maybe blinking there. So that is all perfect. Yeah, now you also see the temperature rising. Okay, that was it. So I did not pay attention there. After box experience of Bamboo is great, very easy. Yeah, I mean, it's just like if you want a tool, then Bamboo Lab is a good choice. I'm just like not a huge fan of the company, to be honest. Just like from their policy. If I would need like an out-of-box printer, I would look for like a Creality or something like that because they're pretty good as well by now. And then you still have the option to be independent of the company. And with Bamboo, yeah, it's like I really don't like the approach they take. Would love to see Clipper on Bamboo though. It's actually a conversation I had this week. Because technically you can swap out the mainboard. There will be like some extra work required because all the connectors are most likely like screwed up and everything. But it would be fun to do, like just for the fun of it. I would like to do it. Or just over inflated and rated. I think they are overhyped for sure. Because it's a printer. Like if you buy a Creality or like any other of the brands that are now around, like a Sobol are pretty great, I think by now. It might not be as polished of an experience. I mean, they're pretty good in like delivering like a polished user experience. That there's no way around that. But if you I really see it a little bit as like the Apple Android 5 years, 7 years ago, right? Where like you had your more like like 10 years ago, right? You had your iPhone 4 and you had your Samsung Galaxy S3 or something. And it's kind of like how I see it because like the iPhone already was back then like a super polished experience, and the Android side was already like a bit or still a bit rough. And then now basically it's on the same level more or less. And that's most like how I see the printers as well. Like in 5 years, all the other manufacturers are like completely caught up. But yeah, I know like if I would need to buy like a off-the-shelf printer right now, I would most likely go for a Prusa, because then you still have like the super polished experience. It's not as pretty as a Bamboo, but like it's a super solid machine. It's made in Europe, so that would be my choice right now. you'll be able to update this printer by printing new parts and using new firmware in 5 years. Bamboo will only last as long as Bamboo wants. Yeah, exactly. That's the thing. Like you're completely on dependent on their will. There's no real way of going out. And the things like what they did now with the new firmware for the X1, like basically they can at any time when they want to prevent you from using any other software than their own slicer to send files to the printer. That's basically what they demonstrated they are willing to do and can technically do. It's quite a thing. Yeah. There's a project to get Clipper working on the Carbon X1. It's making progress, but then they use the same mainboard, right? I mean, my thinking was more like grab like a random ass Big Tree Tech or something else mainboard, put the mainboard in with Clipper and just connect this because it's just steppers. It's just it's the same. It's a printer, right? It's not a spaceship. It's just a 3D printer. It's the same stuff. Is that the Plus firmware? Yeah, the Plus firmware has that new thingy. Like you can still use Orca size or something, but you have to send all. I'm not fully up to date there, so my knowledge might be outdated. You have to use their. They have like a little application that you can install on your machine, and then Orca needs to send the files to that application, and that application signs the print job and then sends it to the printer. And the printer will only accept print jobs that have the signature. That's, I think, how it went down. Bamboo is great if you have no desire to know anything about the intricacies of 3D printing and just want to print. Even the Creality or SU8 take some tinkering to get the reliable state. Yeah, that's my point. Like, if you just want like if you want a tool, the Bamboo is a great option. I personally still would not buy one for that because like I really don't like the company. So I would most likely look for like a Prusa because it's a similar out of the box experience. I mean, I never had a Prusa, so but from what I hear from people reviewing them and everything, like it's a similar out of the box experience. And the Prusa is also like a tool. They allow you to tinker, but like it's out of the box, it works, right? So it really depends what you want. I mean, for everyone watching here, and me included, like this is a hobby. Like we are interested in like building these machines, understanding them, tuning them. But yeah, it's not for everyone. That's how it is. It's the same. I think we had it like a couple of weeks ago already as a topic where like you know some people like spend tons of times like tuning the cars and stuff like that. And it's like a niche enthusiast hobby, and that's what this is too, just without wheels. You didn't configure steppers pin according to your cabling. No, I did not do that yet. That is still on the to-do list. First, we have the extruder. So I just want to quickly finish up the toolhead board first, and then we move to steppers. For toolheads, let me get the camera down again. For toolheads, the next thing we need to do or can check is the fan. I hear a fan. No, it's actually quite strong. It's nice. It's not loud and it's quite strong. I like this fan. So that's there. Then we have RGB. Yes, we have RGB here and only here, not on the bottom. Let's quickly check how this is configured. So basically, we only have this LED here, but the two on the bottom are not doing anything. Most likely, the chain count is not correct. EBB. You know, first important stuff. RGB will be what we need. He will, when he does the stepper bus. Yes, I will do a stepper bus. That was my plan, to just bus them and then we see which one is where and then we can adjust the pins. Prusa similar out-of-the-box experience, but Prusa machines were 2 times the cost of a A1 here in the US until the tariffs hit. Yeah, that's the thing. But Prusa actually produces in the US, right? So if you're like into that with tariffs and shit, like Prusa produces locally. I'm not quite sure if they already do, but like they were building up a production facility in the US. So I think that's for me like one of the big parts. Like if I buy Prusa now, it's produced in the Czech Republic, which is like in the EU, and I think that's quite cool to just support. Because yes, you can produce super cheap in China. That's not a secret. But I think it's worthwhile to support companies that like produce locally. They only make the MK4 in the US currently. Oh, only Mark IV. Okay, but I assume they most likely will also start producing the Core 1 there because it's mostly Mark IV with some other enclosure. Yes, I got distracted. RGB. Here. Yeah, chain count is not defined. And that's 3 for us. I think it's chain count like this. Let's just quickly try. If Clipper complains, it was wrong. Yes, it was correct. And now if we go back and we set the hot end RGB. Yeah, see now we have all the LDs. So the chain count is just basically how many LDs you have in the chain. This one is the first one. So technically you can also define them separately. I actually kind of want to do that, to be honest. Now that I think you can define them separately. Neopixel, is there an offset? No, okay. But later you can basically say only one RGB is red and the other ones are white or something. But you cannot set an offset here. Then let's just leave it as is. Cool. So I think then the toolhead is more or less done. The only thing we didn't check is the end stops. So for the end stops, let's go to machine. And down here you have these end stops. So right now, all end stops are open, which is exactly what you want to see. I'm just pressing the X end stop now. And now we see X end stop is triggered. So this works perfectly. So the X end stop is okay. Then I'm going to push up the toolhead because we have tap, right? And now we see probe and Z are both triggered, which is perfect. So we know the Z end stop also works. And while we are at it, let's quickly check the Y end stop here on the back. Yeah, that's also triggered. Okay, cool. Then all the end stops are working. That is cool. Then I don't really care for the filament sensor too much, but now we configured it, so we kind of need to check that. Let's just quickly. Yeah, it switches to. So that also works. Perfect. Perfect. All important stuff is working. This camera mount is really weird. I really need to get a new one. Okay. Um, they're working on getting it going, but still the Prusa machines are now price competitive. I love the Prusa Mark 3S and XL. Check your color. Looks like you have green coming out of the LD. You mean here green? Oh, it's not green. It's just. Oh, it is green. It is green. Interesting. I thought it was just like a reflection, but yeah, you're actually right. It's green. This one is green. Not sure if you can see that. Yeah, you can barely see it. Like there's a bit of like this one is green. Interesting. That's only It's only this one. Let me quickly reset the color. Sometimes they have a bit of like a jerk. No, but maybe this one is defective because this is still green. Interesting. It's not super high up my list, but yeah, this one is still green. Like no matter which color I set. No, now it's off. Okay, let's quickly check. Oh, I know what the problem is. I know what the problem is. These are different LEDs. The color order is different. So this is the default value. Most likely they are RGBW. Let's quickly check that. I'm not sure if I can put something here to show the color a bit better. Let's quickly, so I'm just setting it to, yeah, now it's white. Yeah. That was the problem. Now the color order is still incorrect. You see, when I put it to green, it goes to red. And when I go to red, it goes to green. But blue is blue. So we need to change green and red in our color order. So basically what just happened, why it wasn't working, like they were different, is we sent GBR, I think, so it's 3 bits, but these are 4 bits. So basically the last LED didn't get data. EBB, what did we say? We need to GRBW. GBRW, Steve? Let's see. Green, red, blue. Yeah, that's correct. I have no clue if I have not said what you said, but it works. There's a macro for LEDs in the stealth burner kit. Yeah, there are tons of macros for that. I also have like a lot of macros for my other machines, where I have different like statuses, have different LED color. But wouldn't that apply to them all, not just one? So angels, the problem is basically because these are GBRW or whatever, so it's like 4 bits. But basically we configured it as 3 bits. So basically if each LD gets 3 bits, it sends 9 bits in total. Bytes, I guess 9 bytes. But now it's 4. So basically it should be 12. So the last one didn't get any data. Then it just initializes to some random ass value, and that was seemingly green now. But then it doesn't change. That's why it was like only for the first 2 and not for all of them. Check. Yeah, so that is all done then. I think we can stepper bus. Let's just we can also check the Nevermore quickly. Oh, we didn't configure it yet. We don't need that yet. Let's not touch that. Let's do the Nevermore when we do the enclosure and the exhaust fan. But then let's do stepper bus. So we say stepper bus, and then stepper is stepper X. So what stepper bus is doing, or what stepper bus does, is just like moves the motor tiny bit forward and backward. So this should result in some wiggle in the tool head. And we are buzzing this one. So I think this is Z0 actually. So now we just need to start swapping steppers. Printer config. Hi there, Pendolo. Welcome. Does the diffuser in the Voron logo came in the kit, or do you have to print it? You have to print that. I actually have this like very small roll of like transparent PETG that I use for that, and I bought it like 3 years ago, and I still didn't use a lot of that. You can check if you find somebody that sends it to you, but I'm also pretty sure you can buy them online on AliExpress for like a couple cents. Yeah, if I swap the connectors, it's more work than if I swap the do I want to swap the connectors or do I want to swap the config? The LDO kit comes with the diffuser, or I didn't know that. I had for the V0 LDO kit, I had to print mine. I see they improved. But yeah, it's annoying because you need a transparent filament for like it's literally like 2 grams or something. So it's a bit annoying. Yeah, so stepper 0 is front left. So let's just copy these values. I quickly do it in config. I'm too lazy to flip it over. And we swap it with stepper X, and then the UART pin also have to swap. PB9 goes here, and we take PC13. Save and restart, and now basically we should get the right stepper bus. So I just stepper bus again. Oh, now we bus this one here in the back. So that's also not correct. I think it's more interesting in the config here. Then we need to swap stepper X with stepper Z2. So this needs to go here. And then PV9 goes here, and we take PG10. Axis motor B, so the left one looking at the printer from the front. Yeah, that's a good hint. Thank you. Which is now buzzing, actually. We're now buzzing the one in the back here. This one is the one buzzing now. So X is now correct. Okay. Then let's buzz stepper Y. Which is now Z1. So we need to swap stepper Y with Z1. And this is PG14. Oh, and this was PE3. Almost there. Yeah, now we buzz stepper Y here on the back. And I think the X steppers and Z steppers should already be pretty much correct. So this should be, we should buzz this one here now. Which we buzz. This moves. Then we just updated this one here on the back. Yeah, this is also moving. Then we have this one here. Yes. And then last but not least, we have the one here on the front, which is a shutdown. Very nice. uh, almost. TMC UART separates that 3 register inf. I'm not convinced about that. Oops, that's the wrong one. Okay, let's quickly check. So stepper Z3. Let's just check here quickly. If we look for PD3. So these are the things, but it's motor 7. In motor 7, we don't have a stepper. I think that's a problem. Ugh, okay, that sucks. So we need to look at our picture. Z3 is this one here. So it's the motor 4. Motor 4. And then we have these pins. So we need to copy them over. I'm just not sure about the UART pin, where it's not mentioned here. Ah, here. Motor for UART is PV5. Save and restart. Let's see. So basically, like, the error now happened because there's no stepper driver in motor 7. So Clipper couldn't communicate with the non-existing stepper driver. Here we go. And it means all the steppers are stepping. Let's also see what need to go where. Oh yes, Steve, that's what it did. First move up, then down. I'm not quite sure what you refer to, Pendolo. I've been building along with you, same kit except 350. Got a little ahead. I had 3 issues, needed to invert Z1 and Z3 direction with exclamation mark LDs, and the filament sensor didn't work for CAN bus. The LDs work for me. I will publish my configuration after the stream, so you can just check if you have something else. The filament sensor, also Mr. The Design mentioned it doesn't work for him. I have a suspicion why that is. I think there was some diode on the chip, why it doesn't work most likely. I remember vaguely, because I have the same board on my switch wire, that there was some problem, and we soldered some cable somewhere to fix that. But to be honest, you can just live without filament sensor most likely. It's not super important. I will remove that actually later. Step 1 and 3 direction pin need to be reversed. Yes, we will check that also in a second. Step by step. So let's go to Clipper for smooth. And that's my most favorite trick. Yeah, it's actually this one I remember now. So we take force move, which is a really cool feature. And we say force move enable true. Restart. What it does is it unlocks a Clipper command. No? Active? Ah. Active. Enable force move. Close. Close. Enable force move. True. Save and restart. What this allows us to do is we can say set kinematic position X 150, Y 150, Z 5. So we basically just tell Clipper, this is your position. Fully trust us. I'm just going to move it up a notch. So if I run this now, you can see this will go to blue. No? Kinematic, pull. No, without typo, and then we get there. So now you see these got blue, and now Clipper says, this is my position. Oh, but I did 15. My bad. Let's fix that. Now it's 150. And now what we can do is we can just say move an x minus 1. So x minus 1 would mean we move this way. And we move in y. So that does not... and minus y is this direction. So the steppers are most likely swapped, or the pins are swapped. Let's quickly check. There is the Voron getting started guide, which, by the way, is kind of what we do now. I just didn't do it to the manual. So if you build this, this is a really good document to just go through to check all the things. And this is the graph I was looking for. I mean, this is V0, but it should be the same for the V2. So we see now basically what I did is like if I move positive in X, I kind of forgot. It moved which direction? Positive in X is? Positive in X is forward, and positive in Y is this direction. So looking at this, we have X, Y, we have these. So stepper B is inverted. That's basically what it tells us. So we need to go to our config. And then in the MAP, and stepper B is stepper Y. So the direction pin here needs to be inverted. I just ran cat5e from the Manta headers for wires, and the filament sensor works perfectly now. Oh, really? Oh, so you run completely run the down to the board. Ah, okay. Well, yeah, you can do that. It kind of defeats the purpose of the canvas. But hey, if it works, it works. Stepper B is X. Is it this way? Yeah, it might be. So now we have X is so just basically the wrong direction. So now both are inverted. Success. No way, you're already done. Well, not done, it's not printing, but we're getting there. So both are inverted according to this. So let's invert both. I mean, there are only that many ways to do that. So oh, that's that, my bad. We invert both. Yeah, X is B. Yeah, you're right. X is B. My bad. But I think now it should work either way. Yeah, so X is plus, that's good. And Y, yeah, now it's correct. So now we inverted a bit more than expected, but doesn't really matter. It works. So just to show a little bit bigger movement. So you see this moves back, moves forward, moves over, moves other direction. So that's good. Then let's go to Z. So I move that up 1. Yeah, and we already saw different. This one for sure went down. Let's fix this one first, because like there's too much going on. I have to focus on one. So the MAP, that is Z3. So the direction pin we invert. Then we set kinematic position again. The only one going down is now the one. MAP, stepper 1. We invert that one. Now we check if, who said what to invert? Mr. DDSI said 1 and 3 direction pin. Yes, you were spot on. 1 and 3 are inverted for me as well. Yeah, now it works. I mean, we're basically having a printer at this point. Let's see. So, let's home step by step. So let's just do G28X. That should home X, obviously. X is homed. So let's move that over itch, and then let's home Y. Okay. Let me quickly clear out, like I disable the motors quickly. Then the position goes away. And then we can just do X and Y. So now basically, oh, that's not what I wanted, but it works. So I always try to home against my finger at first, because then you still have time to quickly hit emergency stop. And you see, like, I'm hovering over emergency stop the entire time. But I'm pretty sure we can home X as well. It's just weird, like, why does it home X? If I say XY, it homes Z. I mean, thank you, Clipper. And now we can quad gantry level. And I think it's alive. I think you can call it alive. We need to set up the end stop positions most likely a bit. Oh, we have to adjust the bad position to be more precise. I like to live dangerously and break nozzles. Live dangerously and break nozzles. Test your set it against the build plate. Well, yeah. I never broke a nozzle. I did break like a bad once. For the first printer I had at home was the Ender 3, and like, man, the first build plate, like, it was like littered with like craters from where like sank the hot nozzle in the bed. Like, it was like horrible. Is the nozzle off the bed one? No, it's not. It's just very, very close to the edge. We have to adjust the bed position. You can also see it's like very, like, not in the corner. I think the bed needs to come forward quite a bit. It also tries quite a bit. So most likely because it's here so close, like, it has a bit of problems. Like Warren Tap Doc says, you need to break in your tap. Well, we're doing that now. But I think we did it. I didn't pay attention. I think it's quad gantry leveled now. But yeah, let's quickly work on the bad position because that is quite off. So now it says Y25, but it's basically on the edge of the bat. So that's the bat needs to come forward quite a bit. Um, that is luckily easy to do because all we need to do is basically just use the correct screwdriver. Step one. And I just quickly loosen the 4 screws here, and then we can shift the bat. I just hope we have enough cable because I remember it was quite short in the end. Yeah, I should find. I think we added extra cable because we already knew we would need to do that. So let me just go to Z5, and then we go to 0, 0, and then we can just adjust it. So this should be like the front corner of the bat. It doesn't need to be like hyper precise, but I think we accidentally nailed it on first try. But this is basically all we need to do. We also need to adjust the Nevermore though. I um I didn't get the tools down because I thought we didn't do any hardware modification today. How wrong I was. I'm sorry for like being in front of the camera. Let me quickly get that up. So I kind of need to see what I'm doing here. So there are 2 screws left and right. Maybe it's a lesson like have the Nevermore all the way to the front when you do this. Come on. It's loose and it's moving. It just doesn't want to come to the front seemingly. There you go. Let's just check, but this looks like a good position. When the bat comes, here, I think this is quite good. Maybe we can push it back like an inch. Just like this. That like the ventilation slits just peek out. That also makes tightening the entire thing a bit easier. Did we use T-nuts for that? Because like if I tighten it now, like it doesn't tighten down. Why should we use T-nuts and the nuts are not in the track anymore? I. Ah, fun. That's something I noticed with the T-nuts from this kit. They usually the T-nuts should rotate themselves into position, and these don't do that reliably. Okay. So they're basically like in the wrong position in the track, and then they don't tighten. Okay, something like that. Let me actually quickly check 300 at the back if we are position-wise somewhere where we should be. Yeah, I think we can inch it like a little bit, inch it a little bit forward. Like there's still like 5 millimeters on the back. Let's just do it like this. Then there's like 2 millimeters front back. Okay. The other thing we didn't do yet, and we need to do before doing anything, is tightening the belts. I think what we can do, like to do a little bit stuff in parallel, is let's move the tool head into the position where we needed to do the belts, and then we can do the pit auto tune for the hot end and the bed while we do the belts. So I'm gonna use this gauge for the belt tension. You can also use like these apps with the hertz. But we quickly need to check the tension values that we need. So if you have a printer, like I highly recommend getting something like this. They also exist on AliExpress digitally. Like I built my own because it's kind of fun. And then you get these tension values here. So then basically the AB belts should be between 180 and 220. I'm just need to check what the refer to printer's documentation for proper belt tension and refer to table as reference pages. Printer should be cold and motors on for this test. Move the toolhead through its complete XY travel to see to set your belts. Let's quickly do that. And then I think we need to quickly check in the Voron manual at which position the toolhead should be when we tension the belts. Just a little bit closer. Magnets and T-nuts. Yeah. I'm so bad with all the comments. I'm so sorry. The Nevermore edge should line up with the back edge of the extrusion. Yeah, it's a bit off now for me, but it's fine. Like there's a tiny bit of space. Like it blows over the bed here. So it should be good. There are some jigs. Man, I missed like a million comments. Probe accuracy test sample 100. Yeah, we're gonna do that later. That's maybe not best for on stream. Remember you need to let white travel for the nozzle brush. That is also true. We'll figure it out later as well. 150 millimeters from Eiler's tool head centered. Thank you. No, I looked it up. Thank you, Alex. It's what I remember. It's 150 millimeters. It's the same for that, 150 millimeters. Then let's quickly just move it completely. We already kind of moved it, but just like to make sure we move it in all corners to set the belts. And then we move it to Y150, which is actually center for us, 150, 150. I will leave it here. What we can do now, because we have to work on the belts anyways, let's also move Z to 150. Pit calibrate, heater is extruder, and target is, let's just do 220 for now. So now the printer will do the pit auto tune cycle. And we can do belts. So, this needs to be on the outside here. I assume, yeah, this one goes, the belt on the inside goes through, so you want to have the belt that you can tension. So I'm just starting with that. Oh, move your Z range entire range. We kind of didn't do that though now, right? We only moved it. Yeah, we kind of did. We kind of did. Then for 2.4 and micron Z, we need 2.5 to 2.8. That's quite the tension actually. Oh, I smell a cheap Chinese hot end. So let me just see if I can show you that. So I'm just having the belt tension here. So at the moment we are at 2. And then I'm just tensioning that to, let's just go with the center, like 2.6 or something. Professional. Am I tensioning this right? I think we need to move the motor up because now the tension. Yeah, the tension should apply here, but it doesn't apply. Oh wait, I'm an idiot. If I tension the right screw, potentially something happens. Um, Ignore that this happened, please. We have the Z idler, of course, on top. I know I did that because I was working on the printer on the poor man's Corx Y I was building, and for the poor man's Corx Y to tension the Z, it's this screw basically. That's why I subconsciously went for the screw. Okay, well, fun. But then the problem now is, do I then have to do this here because like this side? No, we still have to do this side because it's the 150. What type of screw is this? Because we have the tension from the bottom, right? Yeah, inside bottom. Yeah, here we go. Then usually what I do is like I try to reset it sometimes, like that the belt has like time to settle again. Yeah, this is 2.6. Let's do the one on the back. um, Helps to send it and then after a few hours check the tension level. Yeah, like I think in the beginning, like the belts have to like groove themselves a little bit in. So I think especially when you get the new printer, you should check like quite regularly for the first month or so. Like, yeah, depends on how much you print, of course. That looks good. Man, what a fail. But yeah, for the poor man Corks Y, it's exactly this screw for the belt tension. That's why like I it's exactly the same spot. So it's like subconsciously because I was working on the machine quite a bit. It just simply went there. That's quite funny. No, nice. Spot on immediately. Oh, also this one. Nice. Okay. That's the Z. And here we have, yeah, 2. We're actually a bit high already. Yep. And you can also do that with this app and like by just plugging, like you just basically do this and then it gives you like a Hertz number and then that also works. I just find this a bit easier. Okay. That is the belt tension. That also needs to be set to 150 for idols. Yeah, this is 150. We already did that before. Okay, let's see if the pit auto tune is done. Yeah, it is done. And then basically what the Mr. DSI said, because you have the multiple config files, I'm pretty sure that it doesn't apply it automatically. Let's quickly try. Yeah, exactly. It doesn't do that. I'm not quite sure why it doesn't do that. It's a bit annoying, but it is what it is. Then in the EBB, what actually happens if we remove this here? So I just remove it. I mean, now, yeah, we still have to do firmware restart now. But then I wonder if next time it will do that. Because now I would just do it in the printer config. And then we can just say here extruder. And now we just have to do the pit values that I copied from the terminal. That's a bit annoying. That's the only thing I really don't like about having multiple files. But besides that, it's like such a nice setup. Extruder section needed to be in printer config if you want the autosave to work. Now it is in a printer section. So I wonder if it now works in the future. We will not do the pit autotune for the bed now. This will take relatively long. Not super interesting, so let's just skip over that for now. It will work without. But to be honest, I don't think there's anything else we need to do. Like technically we can do a shaper calibrate, of course, but it doesn't really matter. So I would just like start with quickly running filament tuning that we just the extruder to quickly run that. Technically, we can also configure the Nevermore. No, let's do Nevermore later when we do the other one as well. Then let's go to the good old LS tuning guide. And from all of these steps that you should do with the printer, we only will do the extruder calibration. I do have filament. I think. I feel like I lost the Bowden tube. I mean, I have Bowden tube. But that's all Look where I put the bottom tube. Oh, that's maybe we print without bottom tube for the first one. I think it's fine. So let's just position this here. So I have this like little filament thing. I'm just gonna run this over the top here. So, let's just heat it up to like 220. I need a marker. And I need a little guy. So let's just feed that in first. And then I'm just gonna like quickly do like a small like mark at 120. And then we extrude 100 millimeters. Then we measure again and see what's the difference. Same for probe. Yeah, same for probe. The good thing is for the probe, it doesn't really matter because the probe is 0. So I don't think we need to adjust a lot there. What filament did you use for the printed parts? The marble white looks nice. Yes, I love the marble white. It is this one here. It's a Noblefil ABS-X marble white, and it's really good. Like the like it looks amazing and it prints amazing. Like I'm a huge fanboy of that brand. It's the first time I ever bought filament from them. And the black is the same. Like the entire printer is done with the Noblefil ABS-X, and it prints beautifully and it looks really nice. Z offset, yeah, but Z offset should be pretty much 0 because we use tap, right? Like it's not 0, 0, but like I don't expect this to shift a lot. Yeah, so this is 220. So let's just. Oh, I didn't. Oh, I did work on that. Just for me, let's move the tool head like to 50. I want to see the filament. Oh yeah, we have filament pooping out. We are melting plastic. This is still a bit stiff. Like I feel like I worked on that lever, but it's still a bit stiff though. So let me mark 120. And then I'm just going to copy quickly the commands. From the tuning guide, because I cannot remember that, and I'm doing it for a long time already. And now we will see. Does it? Does it actually move? Yeah, it does. Wait, does it actually move? No, it does not. Oh, it extruded 1 millimeter. I copied the wrong one. Oh, okay. Let's quickly extrude 50 just out that I can make a new mark. Well, 25. It's not extruding. I think the configuration for the extruder is incorrect. I feel like it's moving out a tiny bit. Yeah, you see the black mark here? So I'm extruding 25 millimeters. You see how it moves up a little bit? That is not correct. To be fair, we also didn't update extruder config, uh, so most likely this is incorrect. I mean, it's extruding. The direction is wrong. The step first thing is direction is wrong because it's moving the wrong direction. Rotation distance is something we need to check. Still burn or clockwork to config. Oh yeah, because like we have the EVB config. Um, no, no, this is not correct. Voron design. Close. Firmware, clipper configurations. Doesn't really matter which one. Let's just go with the one we had. Extruder. And we need this one here. This is what we need. And then 50, wait, I deleted 50. Yeah, 5010 is what we need. Save and restart. Did you set max as extrude or distance? I did not set any max. Check the origin config for Voron GitHub. I didn't do that, but I don't think we need that right now, to be honest. Let's see. So let's just extrude 5 millimeter. Now we're getting places. That looks kind of spot on. I'm just extruding like a little bit that the mark is gone. So I make a new mark. At 120. And then let's repeat the command, but this time let's do the correct command. That usually helps a lot. Move too long. Yeah. Okay. Mr. Design, there is your configuration needed. Wait, does he say it here? No. This one here. This one. Just do 105. So 220. And now it does it. Yeah, now it's pulling in. No, it's not focused for you. Slowly but surely. And we'll always take a second to like extrude all the stuff, like a minute. While this is running, I mean, this is as interesting as watching paint dry. Let's head to printables. And I'm not quite sure why it always defaults to this. But actually, let's just start with the Voron cube, to be honest. I like them. Let's quickly let that start. 1 second. I did not think far enough to prepare Orca. Prepare. We need a new one, I would say. um, we want Clipper. That's generic. We can also just look for 2.4, right? 2.4, 300, 0.4. Confirm. Here we go. Hi there, Custard. Welcome. You're just in time. Did you fill it with ABS? No, it's PLA. It's PLA. So let's do Voron Cube. And what I really like to do is I just set the wall loops to 2, top shell layers 0, sparse infill 0, and then it creates like a hollow cube, like this. They are like super fast to print, like it's 20 minutes, but you see the entire surface finish basically. It's a very good test. I'm not quite sure if you can see that, but this should say it all. I like to print them. What's the red thing at top of the exterior filament sensor? Yeah, it's a filament sensor. I'm not quite sure if I keep it. Like, I don't really like it because it literally eats away from the Z height. Like this, like just removes like this much Z travel basically because there's a panel on top later. There's a bone tube that kind of needs to go places. So yeah, I'm not a fan of that. Let's also right away set up this Claire. All my printers are names with C. There is Claire. I don't know what device UI means, but this should already. Okay. Oh, I didn't give them names here, but can I still? Voron 2.4. I really have to clean up my Orca configuration. It's a bit of a mess. I think the problem is like when I switched from Prusa slicer to Orca slicer, I used like some tool to import all my Prusa stuff. And it was like super like a very bad idea in retrospect because like my entire database or like all the configuration files of Orca are all messed up for me. It's horrible. I'm new to 3D printing. Then welcome 3D printing. Should I buy Algo Centauri without enclosure for $200 or Sol SVO6 Ace for 260? It's a good question. Like I think they are quite different printers, to be honest. SVO6 Ace. I am not 100% certain. Like, the Centauri is quite a good machine, but it's not running Clipper, so it's a bit more limited what you can do later on. This is a machine you can mod a lot. Because it runs Clipper, you can like do a lot of cool stuff. The Centauri is a bit more limited. I think you won't make a mistake either way, to be honest. Yeah, it's actually like as Mr. DSI said, the Soul is a Batslinger, but has Clipper. The Centauri is a same motion system as this one. It's the Core XY. But I also heard that Steve, who is also in the chat here, is not super happy with his. But yeah. And then what Kassat says, like if you're completely new and you just want to print, Bamboo Lab A1 Mini is actually like a solid choice. But then basically this is just like, it really depends what you want to do. We had the same discussion like earlier in the stream. Like if you want to just print because you want something printed, then I think the A1 Mini would be like a solid choice. But if you want to, you know, tinker with it, improve it, have fun with the machine, then the Sovol, I think, would be the best pick. And the Centauri is maybe somewhere in the middle between the two. And the 3v3 KE is also a solid choice. I think they're quite similar, to be honest. Both are bad slingers, both are clipper. KE is the clipper edition, I think, right? There's so many Ender 3 variants that I kind of lost my bearing there. Yeah, they're both clipper. Also there, you're not gonna go wrong either way with either Sovol or Creality. I don't think there's a lot of give between the two machines. They're very, very similar. They're very similar. Like they have the same print area. I don't think there's a big difference. I want to try 3D printing and know about the technology and later build my own printer and maybe even CNC machine. If you want to build your own stuff, then I would actually then either the Sovol or the Creality, one of the two, but because both machines run Clipper and allow you to tinker and like improve the machine. The first machine I've ever bought was an Ender 3. I'm not sure if I can lift it up now. I think it should be edited. Because we also wanted to check something else with the machine anyways. This is the first machine I ever bought. This is technically like Ender 3. This is technically an Ender 3, but like long ago. But why I'll now pull it out, like first to show you. Wait, that was the filament. So this is Ender 3. And this one we completely rebuilt to like a Voron switchwire. That's like stuff you can then do, like not necessarily exactly that, but like the Ender and the Soul will allow you to tinker a lot and like change the machines later on. And if you buy like a Bamboo Lab, it's just like it's a tool. That's exactly what I said before. That's not a stock Ender 3. No, not anymore. I think the last thing that is still Ender 3 on this machine is the frame, obviously. The frame is Ender 3. The power supply is Ender 3. Yeah, that's it. I think everything else we changed. Because we changed the stepper motors by now. We changed literally everything. But yeah, technically it's Ender 3, but it's not an Ender 3. But what I wanted to check, I remember something was here with this tool headboard. Take a look inside, but I can't see anything. Maybe it was the other board. Maybe I misremembered it because before we had the canvas board in there, we had a different board. I think maybe there we added this jumper cable. I really can't remember anymore. Ender 3NG. Yeah, Ender 3NG is also a cool project. Get this out of the way again because we don't have any space. Here we go. But yeah, that's like if you have like the Soulball or Ender, you can tinker a lot with it, which is pretty cool. Let me rescue my filament here. You know, like I got now like a bigger table here compared to my old place, and it's still like not big enough. Okay, let's print something. What's the holdup here? Yeah, it's a hollow cube. Inject the filament. Steve, you're absolutely correct. I was like so distracted. I completely. Thank you for paying attention. But I actually shouldn't have done that because it's spot on. It's exactly where it needs to be. So we're looking for the bottom of the line here. Can you focus on this one? We look at for the bottom of the line, and the bottom is, I mean, it's looking at now at the camera. Maybe we can like do 1 millimeter. 1 millimeter. Let me quickly update that. So let's go to the EVB extruder rotation distance. Let me quickly pop that in the calculator. So that's the old value. We look for the formula here because, as always, I can't remember. So we have 90 millimeter left. So it's 101. So it's actual divided by 101 divided by 100. So the new value is this. It's not a lot different, like it's from 22.6 to 22.9. Yep. I'm not gonna bother like checking it again. Like this is just like to kind of get it somewhere in the neighborhood of where it needs to be. Off we go. We're here to print, not here to measure filament. It's also like the start G code is completely stock standard, right? Like we didn't add any prime line or something. So I'm curious how this, this will go. I think we have a brim most likely. Oh, we don't even have a brim. Oy, okay, that will be interesting. I'm a huge fan of brims and not skirt. Sorry. I say brim, I mean skirt. Um, is it marble ABS? Yes, it is. Yeah, get a close up. This is marble. It's really nice. Or showed off the filament like a second ago. It's this is the same type. It's the Nobufill ABS-X, but then it's like not gray, but like the marble white. It's called marble white. Really nice filament. I repeat myself. Prints amazingly. Looks amazing. Fully recommended. You didn't calibrate the Z answer position. Do I need to calibrate the Z answer position with tap? My expectation would be no. But the Z offset we can do now, right? Like in a print. I don't expect the first print attempt to go through. I would just like adjust it as we go. It should, like my expectations with tap that it's in the neighborhood from where it should be. And I really want to print. I'm a bit print driven right now. We have the emergency stop is handy. Let's see. Yeah, the start cheat code is definitely funky because like it already heated the extruder up to 220, but now it needs to cool down to 150 again. That's not a deal. So all the macros we need to check. Nozzle to bed 0, but sensor to tap minus 1.2. Ah, that's what you mean. Let's quickly check. Only takes a second. I'll just keep the bed at 60, and we don't have to wait again. Help me. It was set and stop. No? Probe calibrate? Which one is it? Must home. Yeah, probe calibrate. Yeah, probe calibrate. Thank you. Oh, it's a bit complicated now. I mean, I put a E3 PZ on my latest 2.4 build, and man, it's so nice. Benefits of tap without having to mess with the probe setup. I have a PZ on my V0, and I can confirm it's very nice. The only thing, but I think it's like a mini stealth burner problem. I really struggled with the fan messing up with the PZ measurement. Nice thing about tap is you can put the paper back under. Yeah, I think this is good. Something like this. Yeah, so it's actually 2 millimeters off. So it's actually quite a big. Most likely we have to, yeah, do the manually again. The EBB probe. Nautilus Cartographer 3. Yeah, I still want to try one of these eddy probes. It's on my list. I had power outage this week, and it threw off the sensitivity of it. Hoping to get some time tonight to get it back to us. Oh, really? That's weird. I've seen where the Nevermore can cause the PC to trigger if the sensitivity is too high. Yeah, like for me, it's like the hot end fan. So basically, the hot end fan in the mini stealth burner is like not loose, but like it wiggles a little bit, and it causes like some vibration, and then like the PC probe's completely thrown off. And the PC probe has these sensitivity stages where you have the filter on, right? And like even with that, like it doesn't reliably probe for me. So what I did now, basically, I wrote the probe activate, like the activate G code, in a way that the hot end fan is always off. It was actually like not a big deal now, and now it works perfectly. Like all these parts are PC probe hold. And I also have, yep, here, this one. This is the second one. Um, but this one is the standalone. So do you have the standalone one, or do you have the one for the Revo? Because on the 2.4, on 0.1, I have the one for the Revo. But I was wondering if I can use this one on the 2.4 on the bed. Like not on the toolhead, but like on the bed itself. That's something I need to figure out. The only problem with this one is, that's an oopsie that happened for me. Focus? The latch here is broken. That's the problem. So this one, I mean, it works. It's just like you have to somehow fix the cable in place. It's on my to-do list. Let's see what we do with it. I did the Revo kit. Thought about getting one of the standalone ones too. I have Revo on all the Voron printers. It makes stocking nozzles so easy. Yeah, I mean, I only on the other two Vorons I have Revos. On this one, I have a V6 now. Let's see. I'm not quite sure what to do with this one though, because like technically I want to convert it into a tool changer with like 3 or 4 tool heads. And the thing is, like, if you buy 3 or 4 Revos, like you're out like half a printer basically. And by half a printer, I mean like what did we discuss? Like Ender 3v3 KE. It's like 2 of those for like 4 hot ends. So it's quite a investment. So I'm not quite sure if for this one I will go for Revo. I might go for the new Bondtech system in because they launched it like in fall, I think, or like in winter fall this year. That's an option. Or manual like classic tool heads, but then the Revo is I think too expensive for my liking. Um, Cartographer has the Z offset, yeah. And I heard that also the BTT Eddy is supposed to get the Z offset soon. The Index will be a big game changer for tool changing multicolor. Yeah, and the thing is for the Bondtech, the base tool is supposed to be like the tool head is like the smart tool head they call it. I think it's like 250 euros ish. So it's 2 Revos, but at each hot end is only a quarter Revo. So I think the 4 in total will be like 300, yeah, like 400. So might be worth a shot. I need to see. For now, we'll just get this printing and then step by step. BTT Eddy has auto calibrate if you use Eddy NG instead of the BTT macros. From what I've seen, oh, it's interesting. BTT has a new PZ-like sensor for these 6 hot ends. Yeah, also that's something I saw. It was announced a few days ago. Yeah, but it's a full hot end, I think, right? It was not only the sensor. What I have incoming is Triangle Labs hot ends. Because I got them recommended by Ravenkeeper, who is also sometimes in the chat. And these are super cheap. It's like 25 euros for one hot end. And I want to try them out because like if you have the tool changer and like each hot end is like 20 euros or 25, it's like quite a significant improvement over like 120, what the Rabo is. Um, is it reliable? You mean the hot end or the PZ clone? I think the PZ clone is something we still need to find out. I'm hot on the emergency stop. I have no clue what the startup macro is here for this machine. Cancelled. Okay, the start G-code definitely does not work. I think what's missing is it doesn't heat up again to the temperature. Let's check. I think we had the macros with print start. So let's do the G32. 1 second. Let me quickly. Um, Let me quickly take a little look in my v0 config. Which is here. Macros. Print start. I mean, this is a lot more than we want, but potentially nozzle purge is something we can also copy over. Nozzle purge. And then we can also copy over the conditional home. So we just nozzle purge is, I think, good to have. And then brush, 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 brush. Light. We need show. So conditional home. So if it's homed, it doesn't do anything. If it's not homed, it will home. And then the start print. Let's just quickly copy all that over. Oh yeah, and the CHOM, let's use G32 instead of G28. So we do that. Then let's say here we heat up the bed. Then we home brush nozzle is not a thing yet. M104 fan off. Heat up the bed. Then we do bed mesh calibrate. Then we wait. We heat up to the extruder temp. We can't beep. It's a sad story, but we can't do that. Then we do something and relative fan on, filter on is not something we can do yet. Let's just comment it out. And light printing is also something we can do. And then in the print end, we need this one, retract filament. Because we have now 25 here somewhere. Somewhere we have 25. Here. No? Ah, here, 25. So we need the counterpart here. Oh, yeah, it's 25 here. Check. Save and restart. We're getting there. Have you checked out ClipPane? It's an ecosystem of clip configs. It's pretty neat. I didn't do that yet, to be honest. Macros config line 29. What is macros config line 29? Oh, there's Tab is so reliable, especially in a close printer. Well, I hope so. I think Ravo is like really like bit hit and miss for me. Because sometimes the first layer is still off. Like even now with my fanfics, like sometimes it's a bit off. The only thing we need here is a nozzle brush. I never switched to Eddy probe for my Voron. That's never is a hard statement. Oh, yeah, I know what's wrong. So it always heats up. That's not wrong, but like it always heats up to the final temperature. Because in Orca, if I go to my ender wire, for example, transfer, and then the machine G code, you need to do this one here, M90, M109. If you do that, then yeah, we need the whole thing here. Transfer. So basically, we didn't tell Clipper anything. Oh yeah, wait, it's here. Extruder. Yeah, okay, it's here. It's the only thing that I don't want. I don't want it to heat up to the temperature. I just want it to be 0. Because the start G code will like cool down again, and it's like a bit inefficient. See, now it heated up to 220, and now like it cools down to 150. It's like I have better things in my life to do than waiting for it to like heat up and then cool down. So now basically, if we resize the file, it will be it will not heat up. It will then first heat to 150, and then can do its tap thing right away. Temperature Second Charm, always good first layer at any time temperature, and even if you swap your build plate. Yeah, that's for me also like I really like the fact that it's like physically tapping, because yeah, even if you switch the build plate. And I actually have some glass build plate or something that I want to throw on here, maybe something just for texture. Then I don't have to do anything. Oh, and also it's input shaper. But I think the input shaper doesn't have like a huge impact, right? I did the same thing, but use Orca Slicer plus macro to preheat the node to 150, then home, then heat to print temp. Yeah, exactly. That's also what I'm doing. On the V0, it's a bit more difficult for me because I also have to make sure the fan is off. So basically, I set the the minimum temperature for the fan to be on to like 170, and then I cool down to the temperature just below, like 165 or something. And then afterwards, I have to heat up again. Then you also have to set off the heater completely off, because if you heat like if you put the extruder, like the hot end, to 30 degrees, the fan is always on, even if the temperature is below the minimum temperature for the fan. Basically, you print 2/3 the speed tap versus stock carriage. Oh, is that a big of a difference? I mean, for me, speed is not the most important factor. It is a factor, but I think for this specific setup here, the hot end will be the limitation. Oh, we don't have bad mesh. Ah, well, too bad. We can't have it all. Yeah, you have to define bad mesh. We didn't configure bad mesh. We only configured probe. Fair point. And that's not the temperature I wanted. Yeah, it now starts printing with 190, which, I mean, it works, but it's not super good. Yep. Oh, yeah, I have quite aggressive extrusion in the beginning. Let's quickly make sure that all these stay there. We need to set maximum extrusion, max extrude cross section. Machine, EVB, extruder, we're getting there. That's 2. All the small config trouble. Let's quickly reslice this, that we get the latest G-code start macros stuff. Same file, just resliced with the start G-code. See, now it doesn't heat up again. Like it just sticks at whatever temperature, and it does the home automatically because the bed is already there. And just save some time. Is it possible to make an enclosure for bed slinger? Yeah, of course. Of course. There is the question is, what do you want an enclosure for? That's the first thing to ask yourself. Do you really need it? Then there is the IKEA luck enclosures. I think the easiest. I had that for like a very long time. You can do it like this. This is just an IKEA luck table with some acrylic panels. That works. Like also in this, you can also stack printers like that. Like that's the most like the easiest one. And then there's also commercial solutions. You see here, this is commercial. This is a whole printer. This one is like the simple one. It's like these 10s. Yeah, of course, it is possible. One for my Veneo E3 Plus out of PVC and the silver bubble wrap insulation. Yeah, I mean, you can throw a cardboard box over your printer and it's an enclosure. It's like, when I printed the parts for the V0, that was printed in one of these IKEA luck enclosures. But the thing is, like, the enclosure you only need if you print ABS. PETG, maybe sometimes in very specific cases, an enclosure can be helpful, but generally you don't really need the enclosure unless you print ABS. And you mentioned you're new to 3D printing, so most likely you will print PLA for the beginning. That's the most simple material to print. So just stick with PLA for the beginning, and then you don't need an enclosure at all. I definitely have to speed it up a bit. The Z move, or like the horizontal move speed, is quite low. Cardboard box also works well. Yeah, exactly. 90% of what I printed with for the first 9 years of printing is PLA and PETG. Yeah. PLA. This here is PLA. The filament holder back there, you can't see it, is PLA. The things on the stand I have here is PLA. The lamp cover there is PLA. Most things that are not printers are PLA. I was just wondering, I never saw any YouTube video about enclosing a bed stinger as an upgrade. Yeah, because it doesn't make sense usually. That's the thing. Like, you really don't need an enclosure for a lot of things. Um, Even more, an enclosure can be problematic for most things. So for example, if you print PLA, and most people print PLA most of the time. Oh, it's canceled again. Extruder, not hot enough. For what? Where does this come from? Yeah, quadcant level failed, but like after that said, extruder is not hot enough. Let's just try this quickly again. Buying a Core X5 machine is better than making an enclosure. Yeah, but like again, like, do you need an enclosure? That's the point to highlight. Because if you don't need an enclosure, nothing to do, right? Um, so I mean, all these fancy Core XY machines, like the enclosure is not because of Core XY, right? It's just, yeah. I mean, if you want to work with the machine and mod it, like, then go for the Ender 3 or the Sovol. Um, because the Centauri carbon, like, you cannot do anything with the machine basically because not an open system. Like, it's not Clipper. So you can't install any mods or something. You can't do much. If you really want to Core XY, I think Sovol has some nice cheaper machines. Yeah, this is the one you're looking at. Ah, I see, they're all bad slingers. Because this one is also quite a nice one, the Sovel Zero, but it's also like a lot more expensive. Yeah, we're missing it. Oh, from the little I can see, it doesn't look too bad. Ah, it's up. It's not bad. Let's not notch it down a bit. That's more speed than I would have chosen for the first sprint, but here we are. What is it doing? Yeah, it's 5K acceleration and 200-ish. I have to let's see how it turns out. I have the suspicion that the hot end will not sustain that. How much plastic are we pushing here? Yeah, 10 cubic millimeters per second. Could be good. What value did you end up for the Z offset? Around 2 millimeters. Around 2 millimeters. Centauri is still a new device, so no one knows how reliable it's going to be. Yeah, there's also one thing. So Centauri has like it doesn't ship. That's one thing I heard. Like, they don't ship the Centauri at the moment because they have like a lot of orders. And the other one is that, yeah, it's like an enclosed, like, it's a closed system. Like, you can't really add stuff to it. It's a bit of a shame. Maybe in the future there's something, but for now there's not. Oh, one more other thing. There is also the Flash Forge Adventurer 5M. You can also maybe look at that, Kumbo, because this one, there is a Clipper mod. It's very similar to the Centauri Carbon, but there is an unofficial Clipper mod at least, and I know people are using that. It's still not super open because like the firmware here is not perfect, but maybe look at this machine as well. because then you have Clipper, you can mod it, it's relatively cheap, and you have Core XY with an enclosure potentially. And a 3v3K for yeah. Also check, also like a very valid option. Check like second hand. Just check if somebody sells like Prusa Mark IV or something like that, or Mark III. That would be like also a very good machine to start. Like you don't need a lot of like if you really want to get into a hobby and learn, you don't need any of these like super fancy features. Yeah, it looks semi good. Let's see about it. Not zero. No, definitely not zero. You were right, not zero. Ah, shit. Ah, it's back at 190. Yeah, thank you, Steve. Like, I don't know where it grabs the 190 from. If you really want to learn, go for Ender. You'll have so many options to mod and learn. Yeah, exactly. But I'm not sure the new Enders, I think, are a little bit less moddable than the old ones. Like the original Ender 3 and Ender 3 Pro and Ender, the V2, Ender 3 V2. They had such a massive community around them with so many mods. Like, it was absolutely insane. I'm not quite sure how the Ender 3 V3 is because I'm not really like into that anymore. But yeah, the Ender is like always like really good community. It's actually not very loud. I like that. Like the machine is not loud at all. Like neither the steppers nor the fans. People from Discord said either go for the SVO6 Ace when I asked about NS3v3 SE. Yeah, I mean both are solid options. KE is just a better SE. No, there's a difference. The KE has Clipper and the SE does not have Clipper. That's the difference. So if you have the money, go for the KE. The infill is gone. We are missing the infill. No, we sliced without. Because I just want to see like the quality in general. I don't want to wait for like half an hour for a cube. I always print them without infill. 190 maybe default temp because slicer parameters don't match your macro parameters. Oh, that might be that the naming is different. Yeah. Let me quickly check that actually. Because 190 is the default. It's extruder and bad. And here we call it. Ah, yeah, it's extruder temp and bad temp. Oh, what happened? It's paused. What? I didn't pause. Ah, see, I hate filament sensors. The stupid filament sensor is empty. I also just figured out why the surface quality might not be good because we don't have a Bowden tube. The filament is pulling on the tool head. That's most likely where this like issues, inconsistency comes from. Yeah, this sealed the fate of the filament sensor. It will be out. Because it's exactly what I also said with the V0, and it's like deadly annoying. Like if you have a filament runout sensor, it's not reliable. It's fucking annoying. Yep. Much. Yeah, so there's a little bit like inconsistency in that. My suspicion is this has to do with the filament pulling. Let's see if like the top half of the cube is better. Like you see it like down here, right? I can also turn on the LEDs, by the way. Yeah, now you see it, right? There's like something going on here. Yeah, so I have them on full tilt. I had to disable the filament sensor as well on my Voron Zero Tragic. Yeah, I think the Voron Zero filament is not reliable at all. Like I actually tried to mod it a bit because like what I did is like I routed the filament a bit differently. That the filament had like it was bending towards the sensor, but even then it was not really super reliable. I changed out my V0 filament sensor to the BTT SFS2. Much better experience now. The SFS is a smart filament sensor. Yeah, I answered my own question. Yeah, it was on my to-do list for some time, but then like I also like on the V0, I don't really need a filament sensor to be honest. Yeah, it looks a bit better since I removed the tension from the filament, but it's not perfect yet. But looks okay. Besides that, like the Z is inconsistent. Floor calibration, not by a long shot. Like we literally just turned it on and printed. Like there's a lot of calibration that needs to go into this machine. I don't even use the encoder portion of the V0, just the filament sensor part of it. My V0 is use the last of this roll printer. So yeah. No, usually like for me, like the V0 mostly is ABS for me. So I just like all the parts on this machine are printed, like for this machine are printed on the V0. Let's see, another 15 minutes. It's a bit odd. I wouldn't have expected these Z issues. But it's definitely better. Like after this like initial trouble zone here, there's this one line here on the bottom of the Visio logo, but the rest seems kind of okay-ish. Not perfect, but like default config in Orca use ZHop. Oh, they use ZHop. Nah, amazing. I don't like ZHop. Let me nuke that right away. Um, ZHop 0.4. Wow. That's the tallest setup I've ever seen. 0.4. I usually use ZHop only on top surfaces. Because then like if you don't use ZHop on top surface, you sometimes get these like lines on the top surface. I don't like that. And ZHop is disabled. I mean, it prints. I'm pretty happy with that. All the small issues we can sort out. We also have to do shaper calibration. Like, I mean, what I will do on the weekend although I am a bit busy on the weekend, so maybe next week. I will work through the entire tuning guide here. Extruder calibration, first layer. Squish is definitely something we need to work on. Extrusion multiplier, pressure advance we need to do. Flow rate, yeah, let's see what we need to do there. Where's pressure advance? Pressure advance and advance. Shaper calibration, lots of fun stuff to do. Lots of fun stuff to do. For now, like, it's printing, success. Default config Oracle 0.4, check the Clockwork 2 tension screws. You think it's under extruding? Sockley 6, not bimetal, max is output 12. Yeah, we are close to the max here for sure. Like it's 10 millimeters, 10 cubic millimeters per second that I'm seeing peaking here. So yeah, the hot end is definitely the weak point here. I have something inbound that we can swap in, but it might take another like 2 weeks or something until it arrives. I'm pushing the Clockwork 2 for sure. I mean, we can also, because let's just move it down to 60%. Also, acceleration is relatively high. But overall, it works okay. Like, I'm really not... Lots of pressure, yeah. I mean, now we are in the 5-6 millimeter. It peaks to 12 sometimes. Yeah. I think the hot end definitely, like, if you buy this kit, you need to swap out the hot end. Like, there's no way you can keep that. Not saying this is now, like, all the hot end's fault, but it limits the entire machine. Oh, wow. It also prints tilted. Sure if I can show you that. I can't go so low. Wait, here you can see it. Something is not quite there yet. Like it's not 90 degrees straight. Might be something with the belt tension. But this is not quite up to spec yet. PDF hotend is a problem in an enclosed printer intended to print high temper materials. Yeah, this is not a hotend I will use for ABS printing. There's no way I will print ABS on this hotend. I wonder what's up there. It must be the... It's most likely the belt tension isn't even. Would be my guess. Definitely not for 2.4. Like, this is not a hot end I would put in any high-end machine. That's easy enough for us to switch out. I would be at least better if it would be Bioman. Yeah, I think this one is actually the cheapest version at all. Like, it's literally the cheapest hot tap possible. The poor man Corks White has the same one. It's literally the same hot in there. Um, yeah, I'm not quite sure what I will do with it, but yeah. And the poor man is also like in a difficult spot because I tried a lot to tune the machine. Like it prints okay, but it doesn't print very well. I'm not quite sure why or what I need to change to fix that. So I was like working on the poor man like a lot the last couple of weeks, but now I like decided to like put it away for a bit because I got actually quite frustrated at some point. Um, yeah, I need to see what to do there. Like it prints okay. It doesn't like it's not really like up to what I expect it to be. Most likely the structure is just not rigid enough. That's kind of like the conclusion we came to. Oh, yeah, it's also like not straight in this direction, right? It's also leaning like this, like towards this direction. Yeah, it has like super aggressive set hops. Like now I also notice it here. One thing I wonder. Yeah, like the front part is literally like a millimeter higher up than the back part. I'm not quite sure why it's like skewing in this direction. I will have to do some research on that. Like I've never seen a cube like that. It's a Voron pizza cube in all directions, but I don't know why. I've seen something similar with the Poorman Core XY because you also have the belted Z there. And there, like one belt didn't have proper tension and was also like printing like all different directions. Let's quickly check the Z belts. Yeah, belt tension. I also suspect belt tension is not correct. And then most likely all of these artifacts are partially also linked to that. And the Z top doesn't help for sure. But yeah, it's like it's leaning like in like this direction and it's leaning like this direction. Like it leads in all. I definitely keep this cube as a memory. I don't know if Orca can override Z max acceleration. It could, maybe. I'm pretty sure it can. Um, but I don't think it has settings for that. Actually, I'm quite sure where. speed limit for Z is 12 millimeters per second here. And maximum acceleration Z is 500. Check rotation distance. Some of them have moved, and Z rotation maybe is that wrong. Yeah, we only swapped the pin, so it should be fine. Yeah, the pin drivers in printer conf extruder. Printer config extruder? I have it in motion ability in Orca, motion ability. Motion ability, it looks fine. Z 12 millimeter per second. What we have here configured. Yeah, it's around the same here. So it's not super far off. Oh, we're almost done with our pizza cube. Mine at 30 millimeters per second and 300 at 1 amp stealth drop. Yeah, that's pretty good actually. Like 30 is good. So I have a 48 volt power supply, and I have four 48 volt stepper drivers, like the 5160. My plan was, so if we convert this in a tool changer eventually, I will put in the 48 volt steppers, stepper driver for the Z motors, that we get like a fast Z movement. It might have been sent after failing quad gantry level, Steve. That might be might be part of the problem. But I think I have to do what Mr. DSI said. I have to break in the tap. Just do like a proper accuracy with like 100 at the same spot. And then let's see. But to be honest, I have zero expectations for a first print. This is the first print, and it succeeds. Like, it looks like shit. It's like it's crooked, but it succeeded. So I mean, it's still like 5% to go. Who knows? But it's all I want, right? I just want something printing, something that looks like a cube-shaped object, and everything else can come later. Mm, 80 millimeters per second and 5 millimeters squared at 1.2 amp spread cycle. At 48 volts, 300 millimeter per second. Wow, that shouldn't be a problem. Yeah, that's kind of like I saw from, I don't know who, but some YouTube video where the thing just like went up and down like crazy. That was 48 volt. But yeah, if you have a tool changer, like, this really makes a difference. If you like quickly move up to pick up your tool, it makes a huge difference. So let's see. It will be a fun project, like at some point. Like for now, my goal is just to make this print nice. I think it will be like some off-stream work because I have to print like a lot of cubes, just try over and over again. Then next stream, what we gotta do is just build the panels, and the panels and the extraction exhaust fan works. And then for the skirts, I need to see what to do. The skirts I want to print on the machine itself. But that depends a bit then on the hot end. I think it's fine to print a couple of like ABS parts with it. But yeah, this needs to print a bit better than this before we can print skirts. Here we go. It is something. By something, I mean something very special. Like, this is a unique Voron cube, you know? Like, everyone has straight Voron cubes. Only I have a crooked one. And this is crooked in all directions. Focus? Oh, the focus area is incorrect. Yeah, well. Go to the notes set at the end of the stream. So, yeah, it's like horrible, but hey. 245-degree max with the Solid. Yeah, I know. Oh, interesting. There's focus is not the strong suit of this camera right now. Do you see this? It's like gold from the from the heat pad. Interesting. This is dust most likely. And it's also ringing like crazy. It really doesn't really want to focus right now. There's like ringing like crazy. Like this is an absolutely horrific cube, but it's my cube. So that is perfect. But yeah, I'll figure this out. It's most likely what Steve suggested. The quad gantry level failed, and then we ran anyways. The config is I think it's even less than 245 to be honest. I'm not quite sure what I saw here. Yeah, max 250 I see at the moment, which is about right. And 0.8 is not a lot, no. But I don't think we have skipping here. Let's just say like the XY dimension is a neighborhood where it needs to be, so I don't think this is a big problem at the moment. It's I mean also the dimension is somewhat there. It's just like not square. Pretty sure it's belts. But yeah, that's for something else to figure out. I think it would be like a good point to end the stream. We achieved what we wanted. We have a very crooked Voron cube without infill. And then basically, yeah, next steps what I mentioned, like we do the panels. And then skirts we need to see. But yeah, there's a lot of stuff we need to change on this machine. So my goal is basically to finish it up like as intended, basically. And then we start modding it, of course. One thing I already have inbound is a hot end, obviously. So that will be the first thing I think we will do. The only question I have then is whether we, if I do the skirts before, maybe on the switch wire, because I kind of want to have the printer done and then do the modding, just like from a order of operations thing. But then with this hot end, might be a bit difficult to print ABS indeed. So let's see. Potentially also just print the skirts in PLA, to be honest. I don't see a problem with that. Only thing it might be like slightly different black, so maybe oh wait, let's see, I'll figure it out. But yeah, yeah, tuning, panels, skirts, and then we have a printer that is printing. Well, yeah, then I would just end it here. Thank you everyone for tuning in. Thank you everyone for helping and pointing out what I did wrong. And see you next week with most likely solution for that and a more beautiful cube. Until then, enjoy your weekend. See you next week. Bye.